Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are doing 8.2 Angles in a Circle Theorem. What will we be learning? Well, by the end of the lesson, you will be able to determine a missing angle or an arc measurement. Why is this important? Well, these relationships tie prior concepts together, showing how intertwined math is.
Cool.
How will you know it? Well, you'll know you mastered it when you can identify the pattern different theorems use given various types of angles. So basically today you're going to see a lot of what you've already seen. You're going to see some quadrilaterals. You're going to see vertical angles. Boy, are you going to see vertical angles.
Yeah.
And some rays and some line segments and a circle.
Cool.
Let's do it.
All right. So on the front side of notes, if you're using the guided notes on page 23, we have 6 different theorems that we're going to be going over. The first one talks about something called a central angle. So a central angle is going to be an angle where the vertex is the center of the circle. Because all circles are similar and all circles therefore can be dilated, the degree of a central angle is going to be the same as the degree of the measurement of the arc. So I'm using theta for my angle. So whatever degree this is, the measurement of this arc, remember an arc is just a piece of the circle. They are going to be equal, and these are measured in either degrees or radians. So when solving a problem, if you look at the examples on the next page or look at your homework, you're going to basically be setting up equations. So you need to identify that when you're comparing an arc measurement with a central angle, they are equal to each other.
Now the fact that theta, the angle theta is equal to the arc measure should make a lot of sense, because if you think about it, you know, all the way around the circle is 360 degrees, and it doesn't matter, like we said, all circles are similar, it doesn't matter the size of the circle. So if you were to draw like we do with our angles, we always draw that little circle, like
The
piece of a
congruency
circle.
mark.
Yeah, the congruency mark showing it's an angle. Well, on this circle that you have on the screen right now, if we were to draw that in right there, but then continue and go all the way around, it would make this really small circle.
Which would be concentric.
It would be concentric. And the little piece that we're drawing on the inside of there is basically the same angle, and it's going at the same everything as out there on the outside of the circle.
I like to kind of think of arc measurements and central angle like a percentage of the circle. And I'm going to use 90 degrees. 90 degrees is 1/4 of 360. So no matter how big or small the circle itself is, if you're talking about 90 degrees of it, no matter how much, you're using 1/4 of the circle for that angle.
Right. Perfect.
All right, next one, inscribed angles. We talked a little bit in 8.1 about inscribed shapes with inscribed angles, so it should make sense that our inscribed angle is formed by 2 chords where they're intersecting on the circle here. Remember, to be inscribed, the vertex has to be on the circle. The measurement of this angle here, angle theta, is going to be equal to half of the arc. So whatever this arc measurement is, it's going to be twice as big as this degree over here for this inscribed angle, or this inscribed angle is equal to half of whatever this measurement is. So here's the equation and how you would set it up. Almost think of it more like a formula. If you can identify this picture when you're talking about an arc measurement and an inscribed angle, this is how you are going to set it up. That one's going to be very similar to this. So when you have a tangent, so remember a tangent is a line that's outside a circle where it just touches the circle at a single point and then it extends out further the other way, and a chord. This angle measurement is also going to be half of the intercepted arc. And an intercepted arc for all of these, in my head, this is going to make me sound silly, but I picture our angles to be like alligator mouths.
Oh, yeah.
And if it were to bite down, the piece of the circle it's eating is the intercepted arc. So you can see here, like if this is an alligator, it bites down, he's biting down on arc S. So the degree of the angle is half of that piece of the circle.
See, and I always viewed it kind of like as a mouth, and, you know, theta is sort of like that stupid little thing that hangs in the back
Yeah, what is that called?
of your mouth.
I don't even know what
yeah,
that's called.
I think it's called, I don't even know. So anyway, but it's biting down on this like burger pizza thing, whatever that is.
You take it one step further.
Maybe I'm
You're
hungry.
making me hungry.
I'm hungry. All right.
All right. Cyclic quadrilaterals are basically inscribed quadrilaterals. And for this one, you know angle A is going to be half of this arc because it's inscribed. You know angle C is going to equal half of this arc, which because it's an inscribed angle. And if you look, the ends where they're intersecting the circles are the same. So basically angle A and angle C are inscribing the entire circle. Well, if the angle is equal to half of the arc, what is half of a circle? 180. So opposite angles in a cyclic quadrilateral are actually supplementary. They add up to equal 180.
Very cool. And you can have supplementary angles in a quadrilateral, but not in a triangle.
As we learned from chapter 7, because yeah, that made me happy.
I'll let you all think about that.
Yes. Next one, interior angles. An interior angle is just an angle that falls inside the triangle. Notice like angle theta here is 100% inside, not on, not out, anything. So it's formed by two chords intersecting inside the circle rather than on, which is what we've been looking at with inscribed angles. So an interior angle, this angle right here is going to be equal to half of the sum of the intercepted arcs. So for this mouth is biting down on S. You know theta is going to be the same right here because of vertical angles. So if this angle theta bites down, it's going to bite down on P. So that's kind of how I look at it. Whatever angle you're using, the two arcs are going to be from the angle and its vertical angle arc. So you would write this as theta, angle measurement, is going to be equal to half of the sum of the two arcs. Please notice that this is in parentheses because your order of operations would say that you need to add the two arcs together before you can cut them in half and so on. And then the last one is our exterior angle. So if interior means it's inside, an exterior angle is found on the outside. So notice that all three of these pictures, the vertices are outside of my circle. This can be formed by two secants because remember a secant is a line that both enters and exits a circle. You're just not seeing, I just ended it where the two secants are intersecting. Right here we have a tangent, which is always outside, and a secant, or two tangents. So any combination of those three lines can make an exterior angle. With an exterior angle, the angle measurement is equal to half of the difference of the intercepted arcs. So here, if angle theta bites down, it's biting down on F and N. So those are the two arcs we use. Same with this angle theta. It bites down on these two pieces. And then lastly, this angle theta is biting down. If we extend these out so you can see the full tangent, it's actually biting down on the whole circle. You just have to look at how it's being broken down. So we would write that as theta is equal to half of F minus N. I know for sure I used F minus N here for far and near. So the arcs, the far away one is always going to be the first one because it's always going to be the larger one. You don't ever want to get a difference that's negative. That should not have worked.
Now, you can also think of it as one of the ways that I do it. I always label them B and S for big and small. And for those of you that really struggled with subtraction, you know it's much easier to subtract that big number and go big minus small. So with these problems, it's always going to be so much easier on you if you always remember it's always going to be 1/2 the big arc minus the small arc. And you can actually do this on the interior formula as well, because with addition, order doesn't matter. So you could say for your interior angles for that formula, you could still say that it is theta equals 1/2 the big arc plus the small arc. That is perfectly fine.
Yes. For this last one right here, when you have two tangents, I mentioned how you're always using the full circle. Well, what teachers like to do, and you will see this from us as well, they only give you one of the arcs. So that's why I mentioned the fact that you're actually using the entire circle. So if you know one of them, you are going to need to do one extra step. Arc F and arc N, or arc B and S, however you want to use it, are both equal to 360 minus F or N. So the one you know, subtract it from 360 and you will get the second arc that's missing from your formula. So that one's really important. If you only know one of these, for this picture only, you can do 360 minus the one you know to get the second arc. That would not work here because you can see we're not using parts of these circles. So, all right, the rest of notes, we're just going to be practicing these skills. So the first example that we're going to do is actually using two of the formulas. What I notice here is we have this center. So X is actually a central angle. And we know that central angles are equal to their intercepted arc. But unfortunately, I don't know what that intercepted arc is. The other piece is I have two chords right here making that 33-degree angle. Well, I know that that's an inscribed angle. And I know inscribed angles are equal to half an arc. So if I plug in what I know angle theta is going to be my x. That's what's missing. And for my other part, my inscribed angle, I know the angle is equal to 33. So I have these two different equations going, but what I'd like to call to your attention is that the intercepted arc, S, well, they're exactly the same for both of these. So we are able to basically take the two equations and do substitution because they're both equal to that same S. So X can be plugged in right here. So 33 is equal to half of X because we know X and S are exactly the same. So we can substitute S or X in for S. And then to solve this, you are going to simply multiply both sides by 2 to clear out the 1/2, which gives you that X would be 66. Okay, if we look at this, and I would definitely recommend flipping your paper over, looking at your formulas on the other side of your notes. This is going to be two secants intersecting, making an exterior angle.
I think what we should do, Mrs. Weichel, is give them a moment, just a moment, to see if they can figure out which picture on the front of their notes and maybe even which formula they're going to use.
How to plug it in? Sure.
Yeah.
Okay, if you need more time or would like to keep trying by yourself, go ahead and pause the video because we're going to go ahead and go through the problem. So it's two secants, it's an exterior angle problem, so we know theta, the angle, is going to equal half of the difference between the faraway arc minus the near arc, or the big arc minus the small arc. The next thing you will simply do is substitute in what you are given in the diagram. So the angle is given as 2x plus 3. The larger arc, the faraway arc from the angle, is 120, so that gets plugged in first. And then 46 is the other angle, or I'm sorry, other arc that we are using. So you end up with this equation here. The rest of this problem is just simply solving an equation using skills you already have. So order of operations says I'm going to subtract 120 minus 46, giving me an equation of 2x plus 3 is equal to half of 74. The next thing I need to do is figure out, well, what is half of 74? It's 37. And then using subtraction property of equality, I end up getting an equation of 2x is equal to 34. Your last step is to simply divide both sides by 2, giving you an answer of 17. Okay, here is our next one. If you would like to go ahead and try it, you may pause this video to see if you can set up your equation.
I would like to strongly encourage you to go ahead and try it so that way you can check to make sure you're doing okay.
And it might also cue you in on some questions that you may have for Mrs. Netz or myself. All right, so hopefully you notice that you have two tangents. So this is going to be an exterior angle problem. So angle theta is equal to half of the difference of your two arcs. Well, theta is what we're looking for, so that is our variable. The larger arc, you don't know what it is, but you know your close arc or your smaller arc is 114. So this is a problem where you need to do that little extra step. You cannot solve this equation by itself. So before you can solve for theta, you need to figure out what arc F is. So you're going to simply do 360 minus arc N, which you are given is 114. So you know arc F is going to be 246 degrees. So you now know everything you need to know to solve this problem. Theta is going to equal half of 246 minus 114, or theta is equal to half of 132, and half of 132 is 66. So if theta is 66, that means angle, the measure of angle ABC would be 66 degrees.
These are actually really not that bad.
Not that bad. Okay, here is your next problem. You are going to have to use something that you learned all the way back in lesson 1.2 before you can apply what we taught you today.
Wow, that's a long time ago.
All right, hopefully you acknowledge the fact that you are working with interior angles. Interior angles are equal to half of the sum of the intercepted arcs. Well, if you look at where x is and where 98 is, that means you are using this angle, which you are not given. You're looking for this arc, which you are not given, and then you are given this arc as 98. You were taught something in lesson, again, I believe it was 1.2, about two adjacent angles on a straight angle. You know that they are supplementary. So before you are able to solve this problem, you need to figure out that theta is actually 72 degrees because it's the supplement of 108 that was given to you. So you can now plug in everything you know. You know angle theta is 72 degrees. You know that the arc closest to it is 98, and then the other arc you're using is x. Again, as Mrs. Nett said, you don't need to put these in a specific order because the commutative property says you don't need to. You can add in any order you would like. So now I'm going to distribute the 1/2 in. Half of 98 is 49, and then we cannot solve half of x because we don't know what x is yet. Our next step is to subtract 49 to both sides of the equation, giving you an equation of half of x is equal to 23. Your next step is to multiply both sides by 2 to clear out that 1/2, or to divide fractions is to multiply by the reciprocal, and you end up getting that x is 46. Here is your next problem. All right, so we have a secant right here, and we have a tangent right here, so this is going to be an exterior angle problem. So we're going to do theta is equal to half of f minus n. For this one, you're looking for x. So again, we're giving you some of these problems because, yes, you're going to use this formula, but you have to, again, think and look at clues as to what you're asked to find. Think beyond just the formula. That's what you guys are required to do. You can't just plug into a formula and always get the answer right away. If you look at where x is not an intercepted arc. It has nothing to do with the secant and the tangent intersecting. However, if you look at what x is, the arc where x is actually the rest of the circle after you look at f and arc n. So if you were able to figure out the missing piece to this formula, would you be able to then figure out what x is? Yes, because you know circles always equal what in degrees?
360.
So if you know arc n is 56, and you do have enough information to figure out arc f, once you know arc f and the 56 degrees, you can take that away to figure out x. So let's go ahead and figure out what f would be. So we know theta is 43. We know n is 56. We're looking for f right now to help me figure out the answer to the problem. Just like the previous problem, I'm going to go ahead and distribute 1/2 into the parentheses, giving you half of f minus 28. I'm going to use the addition property of equality to move the 28 over, giving me half of f is equal to 71. And then I'm going to multiply both sides by 2, giving you that arc f is equal to 142. So now, again, this is not the answer to the problem because x is still unsolved. You are able to find x right here by taking the total of 360 degrees and taking away the two arcs you know. Well, you know 56, and you now know f is 142. So if you work this out, you end up finding that x is 162.
Tricky, tricky.
And our last problem in notes uses a quadrilateral. So go ahead and maybe pause the video and work this one out if you can. So on the other side of notes, you were given that cyclic quadrilaterals or inscribed quadrilaterals, the opposite angles are supplementary. Well, in this one, we're using angle B and angle D. Those are opposite each other. So we are going to use the fact that they add up to equal 180. You are given that angle B is 15x minus 17 and angle D is 6x plus 8. So you're going to substitute that into the equation. You're going to then combine like terms, giving you an equation of 21x minus 9 is equal to 180. Using the addition property of equality, you get that 21x is equal to 189. And then we're going to use the division property of equality, giving me that x is 9. You would then be able to, if you needed to find the measurement of angle B or D, remember, once you know x, you can plug that back in if you're asked to find the degree of one of the angles. Please note, sometimes students have a hard time with this problem or a problem like this because they remember that parallelograms, opposite angles are congruent. Please notice that these are not parallelograms. This is a whole different type of quadrilateral and a whole different rule. So we are using that they are supplementary.
That, and hopefully you all are realizing that a lot of this stuff, the algebra we're using is fairly simple. And once you get everything plugged in the right spot, these problems are really not bad.
Not bad at all. So that's the conclusion of lesson 8.2, our circle angle theorems. The main thing, really the only new thing from the geometry point of view is, can you identify which relationship is used? Is it going to be the interior angle or exterior angle or central angle or inscribed angle? Like, which formula are you going to use to solve the problem? Once you determine that, if you do it correctly, provided you can solve equations, you should have no difficulty getting the correct answer. So just make sure you are able to identify the picture. It's almost like matching pictures.
You all just totally missed Mrs. Weichel doing air quotes.
I did air quotes on that one.
But you guys can't see us, so.
Thank you for telling them.
I think they should know. Don't you think they should know? I think they should know.
If you are finding that you are not getting the correct answers on homework, the cause of that could be one of two things. You may not be identifying the correct formula to use, or you're not solving your equations correctly. So the first part, I feel like that is something that Mrs. Netz and I could easily fix. So please reach out to us. If you're not solving equations correctly, I ask you to make sure that you are showing every step. You're working it all out, showing your work. Shocking, when you guys show work, you seem to get right answers.
I know.
I don't know why students don't believe me, but I swear it is true. So make sure you're showing all steps, even if you're using your calculator.
Hey, Mrs. Weichel.
Hey, what, Mrs. Netz?
So how many classical geometers does it take to replace a light bulb?
I don't know. How many?
None. You can't do it with a straight edge and a compass.
What?
Apparently the only tools we
Oh,
have
those are the tools. Got it.
those are the only tools we have is
So if I had
straight edge
like
and
a
compass.
tool belt, those would be my tools.
Yeah.
I get it.
Yeah.
That's funny.
That's all we carry is
That's
it. They forgot our protractor though.
That's like our weapon. That's our weapon too. We could be like
There are
geometry
weapons.
superheroes.
They're like our weapons of math instruction.
There you go. All right. Thank you so much for joining us. 8.3 is our next lesson.